Interference is anything that has a negative impact on the receiver's ability to decipher what has been transmitted to that. So an example is, if I'm talking to you, I may not hear anything, but you may have something going on next to you that's impacting the ability for you to listen. And that would just be called interference. Something is interfering with your ability to listen. Well, there's two types of interference. One is called RF interference, and the other is called co-channel interference. RF interference is any non-Wi-Fi source that transmits signals on our frequencies. So an example would be cordless phones, microwave ovens, wireless video cameras. These are all examples of devices that transmit radio frequency but don't pay any attention to Wi-Fi. So those have probably the most dramatic effect of interference. An example of interference would be when we're shooting these videos, the leaf blower guy goes by. Well, if that's so loud that you can't hear me, then you and I aren't going to be able to have a conversation. The other type of interference would be called co-channel interference. Co-channel interference is when multiple Wi-Fi devices occupy the same channel. So, for example, in a normal environment, a Wi-Fi access point and all of its stations are all on the same channel. That's normal. Well, they actually have to contend with each other. When one talks, the other ones don't, and that's just the rules. But there becomes an issue in a large environment when you have multiple access points and you use all your channels, say for example 1, 6, and 11, but when you add your fourth access point, you have to put it on channel 1. So you have two APs on the same channel. If these two access points are within RF range of each other, if they can hear each other during normal transmission, then they will do what's called defer. One will talk and then the other will talk, and they play nice like that. So the word co-channel interference does not really mean that they're interfering like they're butting heads. They're just nice and they take turns. The problem is that an RF channel, a Wi-Fi channel, only has so much throughput. So if you have two access points occupying that same channel and they hear each other, then they have to share that throughput. So co-channel interference, it won't shut down your network like a source of RF interference can, but co-channel interference can dramatically reduce your actual Wi-Fi performance. So Ruckus can mitigate both RF interference and co-channel interference with the same technology. We have a patented beamforming technology with antenna array, and what it does is it focuses RF energy in the direction it needs to go. Now the advantage that has for RF interference is it improves something called signal to interference plus noise. It's just a really fancy term that says the leaf blower is really loud, so I'm going to talk louder than it. So any source of interference, the non-Wi-Fi interference we talked about, is I'm going to increase the amount of signal that you hear to overcome that noise. That's how we mitigate RF interference. How we mitigate co-channel interference is, let's take an example of some common implementations. For example, a long hallway. You'll have channels, APs on channels 1, 6, 11, and then you start repeating to channel 1 again. What will happen is normally two APs on open air like that are almost guaranteed to hear each other because the signals are sent omnidirectionally. With Ruckus technology, we only send the signal where it needs to go. So an example in hospitality or healthcare or education, when your access points are down this hallway, we are going to send the signals through beamforming only into the rooms, not down the hallway where it doesn't need to go 85% of the time. So those two access points that normally would occupy each other and they would have to take turns, since we're sending the signal only where it needs to go, the access points become independent of each other, and what that does is it effectively doubles your throughput. So that's how we can avoid both RF interference and co-channel interference.